Okay, so what happens when we vasoconstrict blood flow to a certain area of the body? This actually happens on a fairly regular basis. We usually don't vasoconstrict all of the blood vessels at the same time. That actually wouldn't make much sense. But we do vasoconstrict blood flow to certain regions. And if we vasoconstrict an arteriole, then what we're doing is we're increasing the resistance, dramatically increasing the resistance, because remember that resistance is equal to 1 over r to the 4th power. So it's not just if you cut the radius in half, you're not just, let me show you, so right, if I go 1 divided by 1 to the half to the 4th power, what I'm really doing is essentially going, my resistance now equals, remember when you divide by a fraction, you multiply it, and so my resistance now equals 1 times 2 to the 4th power. And so it's a huge change is what that ends up being. And so small changes give me a really big effect in terms of how resistance works in an arteriole. So as I constrict those smooth muscles, then I'm going to decrease blood flow. And what happens then is, okay, let's say I decrease my blood flow in this particular example to 0.25. So if my total cardiac output in the example you're seeing here, whoops, not CO2, sorry, is equal to 4 liters per minute, then if I decrease blood flow in one arteriole, I still have to maintain that 4 liters per minute. And so consequently what ends up happening is that the blood flow in the other arterioles increase. And if you add that all up, that still equals my 4 liters per minute. When we constrict the blood vessels, we're doing 2 things. One, we're actually, so the movement of blood out of the arteries into that particular arteriole is a little bit harder to do, right? Because it has to push against more resistance. And so consequently my flow in this particular one blood vessel goes down. And then the flow here, of course, then goes up. And so that's what we're looking at here. Let's go back over here and talk about that in context. If we go back here, and I intentionally use these examples, let's imagine you're really cold and you need to conserve heat. So one of the thermoregulatory processes to conserve heat is you're going to vasoconstrict the blood vessels in the skin. What that'll do is reduce blood flow to the skin, but that's not the only thing it's going to do. Just as importantly, we want to conserve heat by shuttling it into our core muscles. I'm sorry, in our core arteries. And so by constricting the blood vessels in a fairly large area, I mean the skin is a huge structure, and so if we're going to constrict the blood flow in that skin, we're going to push the blood primarily to the skeletal muscles, the heart, the brain. The lungs is not on here, but that's the goal, is to put it to those, surround the vital organs with this blood to keep the blood warm and to reduce heat loss. And so that's an example then of how this actually works in the body.